Welcome back, everybody. We are now going to talk about the last two things in this module. The first thing is a one-tailed hypothesis test for the population mean when population standard deviation is unknown. And then the second thing we're going to look at is tests about a population proportion. That'll be in the next video, that one. For this one, we're going to start here with this example. I'll read through it with you, or better yet, why don't you? No, I'll read through it with you. A business travel magazine wants to classify transatlantic gateway airports according to the mean rating for the population of business travelers. And so a business travel magazine wants to classify airports according to the mean of, for the entire population of business travelers, right? So that's kind of good to know, mean for the entire population. I think that's actually an important word to highlight there. So I'm going to say here, mean, and we'll do, I guess, I don't know. Yeah, I like mixing up the colors. And mean, that's a little bit too dark. It's a little bit too dark, a little bit too dark. We'll go with that one. Mean for the entire population. So that's what we're looking to estimate, right? And we're going to classify airports according to the mean rating for the entire population of business travelers. A rating scale with a low score of 0 and a high score of 10 will be used. And so from 0 to 10, please rate this airport. And airports, and this is will be used, right? Will be used. It's going to be used. It hasn't been used yet. And airports with a population mean rating greater than 7, not greater than and equal to 7, but greater than 7, will be designated as superior service airports. So a sample of 60 business travelers were surveyed at London's Heathrow Airport, which provided a sample mean rating of X bar is equal to 7.25, sample mean. And if you remember our notation for, sample mean, it's X bar, so there's X bar. And a sample standard deviation of S equals 1.052. And if you remember our notation for a standard deviation for a sample, it's S. So there it is. And do the data indicate that Heathrow should be designated as a superior service airport? Should be designated. They haven't been designated, and they're not looking to have their designation renewed, right? It's not like they're already designated and they're wanting to have their designation renewed. The question is should they be designated? And so I'm just going to delete all this stuff here. I don't want you to look at that just yet. And what we're going to look at down here is creating the hypotheses, right? And so if you remember, the null hypothesis is that nothing has changed. It's the current state. There's no change. It's the status quo. And the alternative hypothesis is that things have changed. There's a new state. There's change. So the current state right now is that Heathrow is not a superior service airport, right? It's not a superior service airport. And the alternative, right, which is the new state, the change, is that Heathrow is a superior service airport. So these are the guidelines we have for creating our null and alternative hypothesis. So based upon these guidelines, I'm just going to get a text box here and put this text box out here. I'm going to say that my alternative hypothesis, okay, alternative hypothesis is going to be this new state, right? It's going to be the new state. Heathrow is superior service, okay? And when does that happen? When does that happen? That happens when, and I guess I'll just go to bullet points, and then I'm just going to make this all smaller because bullet points get big. When does that all happen? That happens when the population mean, okay, the population mean, so population mean is equal to, and I guess we could get the notation for the population mean somewhere, but I don't want to show you too much, so I'm not going to go get it. The population mean is greater than 7 is when that happens, right? Because if Heathrow gets a population mean, right, in the surveys, the population of all the business travelers, if they rate Heathrow Airport rating of 7, greater than 7, not greater than and equal to, but greater than 7, then Heathrow is a superior service airport, right? Like that's what the question is showing us here. So if I bring this up side by side with that, so we'll do that one here, and we'll do this one here, and we'll bring that one over. That's not what I wanted to have happen. Control Shift T. That's not what I want. How about we go back this way? That's what I want. So here we go. I want to bring this one over. I hit the wrong key. So, you know, they need to, and I'll just make this bigger so we could actually read it. We'll go up to like 18. We could read that. There we go. And just bring it over there so we have more room, and bring this over here so we have more room, and bring this down. All right, and with that, we could even maybe go up to, we'll go up to like, let's keep going up a little bit. I guess 24 works. Perfect. All right, so that's going to be our alternative hypothesis, okay, is that the population mean is greater than 7. The null hypothesis is that Heathrow not superior service. Like, that's the current state. Maybe there is no rating, right? Maybe they were never been rated and there is a rating, they've never earned it. But the current state, the status quo, is that it's not superior service. And when does that happen? That happens if the survey reveals that the population mean is less than or equal to 7. So you kind of just have to think through the population mean. If you're going to have equality, the one other rule, so these are the 2 rules for the population mean right there. And so I'm just going to go back to this one here. And well, I guess it's kind of nice to see them side by side as you're thinking about this, because you could pause the video. But these are the rules for determining our null and alternative hypotheses. Is, you know, these ideas of the status quo, no change, current state, nothing changed. That's the null hypothesis. And so in this situation, the null hypothesis is Heathrow is not superior service, because that's the current state. And to have that be true, the population mean has to be less than or equal to 7. And conveniently, the one other criteria we use for determining our null and alternative hypothesis is if you're going to have equality in your hypothesis, whatever it is, it's got to be in the null hypothesis. So that's, you know, like, I don't know that with total definitive certainty. Like, that would be a good ChatGPT question. I have something to tell you about ChatGPT in a second. But you know, that warrants further investigation and research. But I'm pretty sure, I've read that a couple times in the book, that the null hypothesis is where you put equality if you're going to have equality, less than or equal to. And then the alternative hypothesis is the change. So this is our hypothesis statement. And now that we have our hypothesis statement, we can start trying to solve this. And we're going to solve it for using like the framework, using the formula, the mathematics that have been developed for us in statistics, for solving a one-tailed hypothesis test for the population mean. And we'll get to that in just a second. But before we get to it, I want to show you this ChatGPT, because I asked ChatGPT, why did you choose the null hypothesis to be that the population mean rating is less than or equal to 7? And so you could read this explanation from ChatGPT, and it reiterates a lot of what I just shared, but it's also good to hear it from another perspective. And so I would take a gander at that if I was you. So pause the video, take a gander at that. So now there's this one thing I want to tell you about ChatGPT, but before I tell you that, I got to turn down the AC, so hold on one second. All right, I'm back. All right, so the one thing I want to tell you about ChatGPT is I used the free version of ChatGPT today in class, and it was confidently wrong, which means it gave me the wrong answer with great confidence. And that was the free version. And so you want to make sure that for the highest accuracy when using ChatGPT, you pay that $20 a month to use the $20 a month version, and you get ChatGPT 4.0 or whatever the most current version is. And using the most current version for months now, I have yet to come across one mistake. But in one quick session of using the free version, because I wasn't logged in at a computer at work, and I used it, it gave me the wrong information. So you want to make sure you're using the paid version, just because that could create a lot of headaches if you're like, how did it get that answer? And the free version is not, for me this afternoon, was not reliable. And I'm not sure how often that happens, but like once in, I don't know what the time period would be, is like enough to create many headaches. So given this problem here, the thing you need to know to solve this problem is that there's a new formula we're going to work with. And that new formula is this formula here. That formula is the same as this one. I just put it in 2 locations, right here and right there. And I put it down here so that we could compare it to the formulas that we've been working with previously. And so the formulas we've been working with previously are right here. And in particular in this chapter, we already worked with the situation where doing a test statistic where the population standard deviation is known. Now we're dealing with a test statistic where the population standard deviation is unknown. And the only difference between these two formulas is one, we're going to use the z distribution table to look up our probability. And this one over here, when population standard deviation is not known, we're going to use the t table to look up our probability distribution. And in this formula, we use the population standard deviation right here. And in this formula, we use the sample standard deviation right here. And then this one here, we're already familiar with. And that one's for doing our confidence interval. All right, so to solve this right here, we need to detail out all of our information. And I have that all detailed out for us just to save a little bit of time. And it's all detailed out right here. So we have the null hypothesis. So I'm just going to actually switch these, null hypothesis. We'll put null hypothesis there, and I'll just bold that because that's what we did. And then we'll switch this one, and we'll make this one bold, and we'll put the alternative hypothesis right there. But the null is population mean is less than or equal to 7, and the alternative is population mean is greater than 7. And then this problem, the way it was given to me in this presentation, is it didn't specify level of significance. But later down here in the presentation, when it's solved by the people who created the textbook, they use a level of significance of 0.05. So I just added that to this description right here. And so our level of significance is 0.05. That's our alpha. And that's what's going to be in one of our tails. This is a one-tailed hypothesis test. Because what we're testing is this value big enough? Is the sample mean big enough with 95% confidence? So if our level of significance is 0.05, our confidence level, confidence coefficient is 95. So is the sample mean big enough with 95% confidence and given a certain standard deviation? Is it big enough to say with 95% confidence that the population mean is greater than 7, right? So you could rewind that video and play that again. And so here is our level of significance, and that's going to be up in one tail. So we're going to see it up here in this tail because we're wanting to see, is it big enough to make it up there? And if it makes it up here, we're going to reject the null hypothesis. And remember, here's the null hypothesis. The null hypothesis is that the population mean, the status quo, the current state, the population mean is less than or equal to 7. And we're going to reject that if it makes it up here, because we will have found through our sample data to determine the population mean based upon our sample data, and our sample data's standard deviation, its variance, right, is that we're going to say that this is big enough, the sample data, to say that the population mean with 95% confidence is greater than 7. So we're going to reject the null if we get up into this one tail right here. And so that's going to be a one-tail test. And that takes some thinking through, like which tail, because earlier we were dealing with this tail down here. And I'm going to leave that analysis to some later point. I'm just going to make sure I'm still recording. I didn't leave it on pause. Good. And we were dealing with the coffee cans, and we were saying, hey, is it greater than, has more than 3 pounds been filled? And so you kind of have to think it through to figure out which tail you're dealing with. And we were dealing with that end on the previous one. So here is our sample, and that's our sample size was 60. You can see that right here, sample of 60. And then our degrees of freedom is our sample size minus 1, so that's 59. And when dealing with a t, sampling distribution, probability distribution, I'm not quite sure what the right phrase is right there, but when you're dealing with t, you need to have the degrees of freedom. So there's our degrees of freedom. Our sample mean is 7.25. So here's our sample mean. And then our sample standard deviation is 1.052. And if we take all that and plug it into this equation, we get this information right here. And so I'm just going to make this larger so we can see it closer up. And so here's that information, right? And so we get all of these formulas, and you can see how all of this plugs in over here. And I think I'm done, but I'll leave it up just in case we need to come back to it. I was going to close the other slide. And so when we calculate all that, we get t is equal to 1.84. And so we could graph that. We could start to graph that out. And we're going to have a probability value, and we're going to have a t-value. And here's our t-value, 1.84. That's what we just calculated. And then we need to find this probability value right here, the p-value. Right? So this would be the critical value approach. This would be the test statistic. This would be the critical value that we're testing it against. And we got 1.84 from doing this math. Well, what is that p equals 0.035? How do you get that? Well, with 1.84, we don't go to the z table, right? Where, you know, that's where we were able to calculate our probability. At the z table, we'd have some value. And we'd say, okay, at this z value, z of whatever, we would have like this probability. And we get whatever that is under the probability distribution right there, what the probability is. But at the t table, we have a slightly different one. And we're dealing with 59 degrees of freedom. So here are my degrees of freedom, df. And we have 50 and we have 60 degrees of freedom. Those are our two choices right there. And we're dealing with just one second. Let me just look this over and make sure I say this correctly. All right. So we're dealing with 59 degrees of freedom. And we have our t is 1.84. And so we can't go to 59, but we could go to 60. And we're looking for 1.84. And 1.84 falls right between these numbers. And so if we zoom in on that, those numbers are 1.78 and 1.91. And so 1.84 at 59 degrees of freedom, right? Here's 60, here's 50, but it's going to be right between those numbers. And if we look at what's right between those numbers, we have between 0.03 and 0.04, right? 0.03 and 0.04. And so for our probability, we got 0.035, which is halfway. Now you could just sort of estimate that. And you can say, hey, good enough. But you can also use a spreadsheet to calculate that for you. So if you go to like Google Sheets, you can go to Google Sheets. And then at Google Sheets, you could click your formulas over here. And you could choose Learn More. And so you could go to Learn More. And then in here, you could search for distribution. All right. And here is a whole bunch of statistical stuff. You'll see the type. It just has statistical over and over and over. And down at the bottom, we have t distributions. And so here's the stuff about t distributions. And I read through these different t distributions. You can see t distribution, t distribution, t distribution, t distribution. And then I read through these formulas. And I learned how to use them. So you could read through the different formulas and figure out how to use them. And so when I did that, and I did this a couple of times, because I've actually recorded this video a couple of times just to be able to say it right. But I could come here and I could say, and the formula that I want to use is going to be t distribution right. So it's equal to t. How did I learn this? I read about it. T distribution right. I put that formula in. And then my x is my t value. So I'm going to enter that right there. And then I have to enter my degrees of freedom. So this is telling me I need to enter the x and the degrees of freedom. And so I'm going to enter my degrees of freedom. And when I press enter on that, I get 0.035, right? Which is my p-value right there, 0.035. So we could start to do this distribution. And here we have the hypothesized population mean of equal to 7, or that's where it would be equal to 7. And we have our test statistic of 1.84, and we have our p-value of 0.035. And we know that we're doing this at the 0.05 level of significance. And so that is right here, level of significance is 0.05. So 0.05 is right here, and 5% of our data will be in the alpha area right here, and this is the reject area. Just one second. I gotta change my ringtone, hold on. So we have this 0.05 p-value. And then the last piece we need to find is this 1.671 critical value. So with this formula here, we went from our t-value of 1.84 to our p-value. And now we have our p-value, and our p-value is over here 0.05. And at 0.05, we need to somehow get to our critical value of 1.671. And just one moment. So here at the 0.05 in the upper tail, if we follow that down to 60 degrees of freedom, we get 1.671 right here. And so that 1.671 is that critical value. And so that's how you calculate these different things. And when you have these numbers here, you can see that our calculations came up with these numbers here. So whether you use the p-value approach or the critical value approach, both of these numbers fall into the reject range. And what we're rejecting at 95% confidence is that the population mean is less than or equal to 7. So we're rejecting the null hypothesis, which means that the alternative hypothesis is that which prevails. And the alternative hypothesis is that Heathrow is a superior service airport. And so if you look through the slides here to see how they explain all that, they come to the same conclusion. And you can see here, Heathrow should be classified as a superior service airport, same conclusion. And their methodology is based more on these rules that you have to memorize. And I'm not a big fan of these rules. I'd much rather draw it out and like understand it from drawing it out. And so here is how I drew it out, and here how are those rules. If you want to read through those rules, maybe they will make sense to you. You can take a look at those. And then you can also take a look at this information. So we'll just go through the other information which is provided in the presentation here. The format of the t-distribution table provided in most statistics books does not have sufficient detail to determine the exact p-value for a hypothesis test. However, we can still use the t-distribution table to identify range for the p-value. An advantage of computer software packages is that the computer output will provide the p-value for the t-distribution. Okie dokie. And then here we have the hypotheses. And so that's what we also came up with, level of significance. And then the t-test statistic 1.84, we came up with 1.84 also. And then here they do something where they, let's see, compute the p-value approach, compute the p-value for 1.84. The p-value must be less than 0.05, t 1.671, and greater than 0.025, t 2001. So the p-value is between 0.025 and 0.05. And because p-value is less than alpha of 0.05, we reject HO. Right, so they're looking at somewhere in the t-table 1.671 to 2001, 1.671 to 2001. I'm not sure where they're getting that from. Just one second, let me see if I can find it. Okay, so it's right here between, let me just back this off a little bit so we can see a little bit more. And one more back off. And so between 0.05 and 0.025, if you follow 0.025 down, here you have 1.671 to 2, but they have it to 2.01, but this is at 60 degrees of freedom, so at 59 degrees of freedom, maybe that's 2.001. And so that's what they have right here between probability 0.05 and 0.025, that's where the p-value is, when alpha is 0.05, so p-value is less than 0.05, so they use those rules to reject. And determine the critical value approach. Our value was 1.84, and they come up with 1.84, and 1.84 is greater than 1.669, so you reject, and they got 1.669. I'm not sure where they got that, but let me see if I could find that. And we have 1.671 because here that t of alpha 0.05 is 1.671, so 0.05, 1.671 right there. And that in our diagram is this, 1.671 at 0.5, and our 1.84 is this, and it's greater, so we reject. And that is pretty much what they're saying here. And then, wait, let me just take, this is the p-value, here we go, 1.84, 1.669, t is 1.671, I gotta see this on two slides, hold on, whoop, 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 and bring this one over, and bring it to the right, and we'll bring this one over here. And I'm looking for our graph over here on this side. And so our graph is 1.671 is right there. And our t-value is 1.84 and 1.84. And then they have 1.669 here. So maybe that's a calculation they did just to get it more accurate. But it should be 1.671. Maybe that's a typo on their part. 1.669. I'm just looking to see if there's 1.669 in here. And maybe that's when you calculate it precisely. So we are looking at it at 60 degrees of freedom. and it needs to be at 59. So little nuances. All right, that's doing a calculation for this situation, a one-tailed hypothesis test of the population mean when the population standard deviation is unknown. And I know it's a lot to wrap your head around, but you just got to work some problems. So you could go to ChatGPT and stick this in and say, give me some problems. You could do the problems. You could let me get rid of this one. You could use this formula. You could draw these diagrams, and then you could see if you got it right. And that's the best way to master it. All right, see you in the next video where we're going to talk about population proportion.